Hello students, in the chapter alcohol, phenols and the ether, today we are going to study about the alcohols. We will subdivide the whole of the content into the classification of alcohols, nomenclature, structure of the functional group alcohol, their preparation, and finally the properties. Now, first of all, we will go for the classification of alcohols. First, on the basis of the number of the hydroxyl groups present in the organic molecule. If one OH group is present, the alcohols are known as monohydric alcohol. If two OH groups are present, then it will be a dihydric alcohol. If three OH groups are present, we will call it a trihydric alcohol. In case the number of OH groups attached is more than 3, we will call as a polyhydric alcohol. The examples of the monohydric alcohols, they are ethanol, propane-2-ol, 2-methyl-propanol. Many more examples are also possible. For dihydric alcohol, the examples can be 1,2-ethane diol, also known as glycol, 1,3-propane diol. For trihydric alcohols, the examples can be 1,2,3-propane triol, commonly known as glycerol, and 1,2,3-butane triol. The example of the polyhydric alcohol is sorbitol, which is used in many of the cough syrups. Second method of classification, that is on the basis of the hybridization of the carbon atom to which the hydroxyl group is attached. For sp3 hybridized alcohols, they can be of following types: primary alcohol, secondary alcohol, tertiary alcohol, and allyl alcohol is also belongs to this sp3 hybridized carbon atom alcohol. For primary alcohol, the OH group is attached to a carbon atom, which in turn is attached only to a alkyl group. Rest two of the valencies are satisfied by the hydrogen. For secondary alcohols, the OH group is attached to the carbon atom, which is attached with the two of the alkyl groups, and the fourth valency is satisfied by the hydrogen atom. For tertiary alcohols, it is the OH group attached with the carbon atom, which is in turn attached with three of the alkyl groups. Here in our slide, these alkyl groups are represented by the methyl groups. Another one is your vinyl alcohol. The structure of vinyl alcohol is in front of you. This is also sp3 hybridized. Sorry, this is sp2 hybridized. Allyl alcohol structure is this one on the right hand side, where the OH group is attached to the carbon atom, which is in turn attached with another alkyl group. Now we will go for the nomenclature of alcohols. First, count the longest carbon chain from the lowest position of the alcohol. That means you look for the carbon chain and locate the OH group and start counting from that side where from the OH group comes first in the carbon chain. You may need to count from right to left and at times left to right at other times. That depends solely upon the presence of the OH group and its location. Carbons will appear as the capital C or sometimes as intersections between the straight lines, depending upon the diagram. Say bond line diagrams are there, or the complete structures are there, or the condensed structures are there. That is how to be understood. After counting the number of the carbons, choose the matching alkane name. Say one carbon atom is there, so name will be methane, 2 means ethane, so on and so forth. Then drop the E from the end of the name and add the suffix OL to the name of the alcohol. Say from methane, methane spelling is METHANE. So last E will be dropped from there, and in place of it, if you will attach OL, the name will become methanol. For ethane, it will become ethanol, propane, propanol, butane, butanol, pentane, pentanol, so on. Use a number in the beginning of a name as a prefix to indicate which carbon the alcohol is branched from. So if branches are present, then this rule is to be followed. Including the additional substituent groups of the alkyl groups are branching from the main hydrocarbon chain, as well the list substituents with the number of the prefix indicating their position in alphabetical order prior to naming of the alcohol. So if the number of the substituents groups are present over there, they are to be arranged in alphabetical order irrespective of their positions. So for practice, you can see the first one is methyl alcohol, which will be known as methanol. Second one is your propane and propyl alcohol, we will call it as propane 1-ol. Reason being the OH group is attached to the first carbon atom. Next one is propane 2-ol, which is also commonly known as isopropyl alcohol. Next one is your butanol. If the OH group is attached at the end of the carbon chain, in the common nomenclature, the small n is prefixed before the name. So in this case, it is written as a small n hyphen butyl alcohol. So IUPAC name becomes butane 1-ol. OH group attached to the second carbon atom, which is a secondary butyl alcohol. Now it will be known as butane 2-ol. Next one is your isobutyl alcohol. Next is tertiary butyl alcohol, and the last one is glycerol, and their names will correspondingly will be 2-methyl propane 1-ol, 2-methyl propane 2-ol, and propane 1,2,3-triol. So this way we can practice the naming of the alcohols. Now next one is your preparation of the alcohols. Alcohols can be prepared easily by the addition of the water to the alkenes, and this process is known as hydration. So in the first case, we can see that the molecule of ethene is first of all attacked by the proton. That proton is added, and after the addition of proton, a molecule of water is attached over there, and from the molecule of water we can see there is a loss of the proton, which is gained by another new molecule of water. That is how the alcohol is prepared in the presence of acid, by the addition of water. Another method is hydroboration, oxidation. We must know the name diborane, which is a dimer of BH3, that is borane molecule. Now, how it is helpful in the preparation of an alcohol? If you take a molecule of propene and add the borane to it in the presence of the tetrahydrofuran, what you will find that the borane molecule is attached to the site of the unsaturation as per anti-Markovnikov rule. That is, positive portion is attached to the carbon atom having a lesser number of hydrogens attached, and the negative portion, that is BH2 molecule, is attached to the carbon atom having the more number of hydrogens attached there. You see that it will react with another molecule of propene. Reason being, this BH2 is still having two of the hydrogens attached, which can be added to the site of unsaturation in the propene molecule. So two different steps will be there, and ultimately what you will be getting is tri-N-propyl borane. Now to this molecule, if you will add the hydrogen peroxide, the lysis of the bond between the boron and the three of the propyl molecule propyl groups will take place, and this boron will be replaced by the OH groups, and that is how the propanol is prepared by this of the method. Now alcohols can also be prepared from the carbonyl compounds. Carbonyl means the compounds which are aldehydes and the ketones. From the alcohols can be prepared from the aldehyde and the ketones by the reduction. If you are taking any of the aldehydes, you will get the primary alcohols as the product. If you are taking the ketones, you will get the secondary alcohols. Aldehydes and ketone can also be converted into the corresponding alcohols with the help of the Grignard reagents. The Grignard, if you take formaldehyde, react with the Grignard reagent, and in the next step, if you will go for the acid hydrolysis, what you will get is the primary alcohol. If you will take the aldehyde, which is in which the carbonyl group is attached with at least one of the alkyl groups, in that case you will be getting a secondary alcohol, and in case you are taking the ketone, the final product will be following the same procedure, will be tertiary alcohol. Now preparation of alcohols from the carboxylic acids. Now we know that this is a reduction process. So propanoic acid in the presence of reducing agent like lithium aluminum hydride followed by the acid hydrolysis can be converted in two steps to the propanol. Same way, if you take an aromatic acid like benzoic acid, you will get the benzyl alcohol. Now some of the chemical reactions that are being shown by the alcohols. Now alcohols on oxidation with the acidified potassium dichromate molecule, you may get if you take the primary alcohol, you will get the aldehyde. If you are taking the secondary alcohol, you will get the corresponding ketone, and if you are taking the tertiary alcohol, no such reaction takes place with the help of the acidified potassium dichromate solutions. Now further also you can see that the primary alcohol which we have converted into aldehyde, if you carry out the oxidation further, this aldehyde will change into the carboxylic acid. Next, if you are carrying out the dehydration of the alcohol in the presence of some concentrated acid like sulfuric acid and heat, you will get the two different products. If you are carrying out the reaction at 140 degrees Celsius and you are taking the alcohol in the larger quantity while the sulfuric acid is in the smaller quantity, the product will be ether. And this conversion is sometimes asked in the board examinations also. Next one, if you are taking the sulfuric acid in excess, and remember the temperature is more than the first case, you will get the corresponding alkene. Alcohols also show another characteristic reaction which is known as esterification. Reason being the final product is an ester along with a byproduct of water molecule. So in this reaction, alcohol reacts with the carboxylic acid. In the presence of concentrated sulfuric acid, you will get the corresponding ester. So that reaction is known as esterification. Now in the end, we can see that whatsoever we have read till now, or we have understood, whether we have understood or not. So in order to test yourself or in order to test the students, these questions may be asked. Write the formula of the allyl alcohol, the vinyl alcohol, as we have seen in the classification of the alcohols. Next one is what is the suffix to parent hydrocarbon name while naming the alcohols. It is all, methanol, ethanol, so all is there. What is the full form of the THF, though it is not represented in any of the slides, but during the explanation I have given you the complete full form. Then next one is how to represent the polarity of the carbonyl molecule. This one is related with the addition of the Grignard reagent with the carbonyl groups. And the last is name the product of the reaction between the alcohol and the carboxylic acid just now completed. That will be an ester.